Let's do the analysis of edge cover. Now we will do the analysis of edge cover. What do you think? What is the size of edge cover? Like, remember, edge cover exists. I told you edge. This is the first thing we know. Edge cover exists if and only if edge cover will exist. Edges which will cover vertices. Edge cover exists if and only if minimum degree should be greater than 0. Minimum degree should be greater than 0. I can say edge cover exists if and only if no isolated vertex. So you should not have any isolated vertices. Okay. Now let us assume there is no isolated vertex. Assume. Okay. Assume there is no isolated vertex. Assume the minimum degree is greater than or equal to greater than 0. This is the minimum degree. Then tell me, what can you say about beta dash? The size of minimum vertex cover. The size of minimum edge cover. The size of minimum edge cover. That means beta dash. What can you say about this beta dash? This size, what can you say? What observation you can make? This should definitely, what should it have? The size, this should definitely be greater than equal to what? N by 2. Yes or no? The size, this should be definitely greater than equal to N by 2 seal. Yes or no? Why? What is the reason? Because you can notice that one edge will cover how many vertices? The idea is very simple. Let's assume these are your vertices. Your vertices are A1, A2, A3, A4, A5, A6. And let us assume that the delta is greater than 0. It means minimum degree means there is no isolated vertex. Now in this situation, tell me what will be the minimum edge cover? The minimum edge cover, what that will be? Then you can notice one edge will cover 2 vertices. Yes or no? 2 vertices. Okay, if I take one edge, then 2 vertices will come. Yes or no? 2 vertices will come if I take one edge. So these 2 vertices are gone. One edge will give you 2 vertices. One edge will give you 2 vertices. One edge will give you. Okay, tell me. So minimum how many we need? Minimum how many we need to cover all the vertices? Minimum. So minimum we need 3. Yes or no? Yes or no? Minimum we need 3. Because one edge will give you 2 vertices. If I take one edge, E1, then it will give you 2 vertices. So minimum 3 we need. 2 vertices, 2 vertices, 2 vertices. So at least, okay, there can be more. So remember, this beta dash, this should be greater than or equal to N by 2 seal. Can I say that beta dash is equal to N by 2? Can I say this is equal to N by 2 seal? Can I say this? That this is equal to N by 2 seal. This is equal to N by 2 seal. Tell me, can I do this? No, this is not correct. This is not correct. Because you can have this type of situation. So at least 3 edges we need. So in the minimum edge cover, at least 3 edges we need. At least 3 edges we need. But remember, it does not mean that 3 edges are enough. For example, consider this: A, B, C, D, E. Okay, F, G, H. In this, what is the size of edge cover? What is the beta dash? What is the beta dash? Means size of the edge cover. That will be 1, 2, 3, 4, 5, 6, 7. This will be 7. You have to take all the edges. In this question, you can notice you have to take all the edges. So you can notice beta dash is equal to 7, and this is not equal to. This is not equal to how many vertices you have. So you have 2, I think. So 5, total 8. 8 divided by 2. So beta dash is not equal to 8 divided by 2. Is this clear? So basically, the edge cover should be greater than this. Means minimum these many edges you need. Because one edge will give you 2 vertex. This one edge, this will give you 2 vertex. Another edge can give you 2 vertex minimum. These, okay, maybe more. But the point is, minimum you need 3 edges. Yes or no? Is this clear? So at least 3 edges we need if you want to cover 6 vertices. The same thing you can do for example, 7. If you have 7 vertices, minimum how many edges we need? Minimum edge cover. So you can notice one edge will cover only 2 vertices. This will only cover 2 vertices. So if you want to cover all the 7 vertices, then you need at least 4 edges. E2, E3, E4. At least 4 you need. At least 4 you need. There can be more. There can be more. So at least 4 you need. I can say at least 4 edges you need. At least 4 edges needed. This is only at least, because there can be more. You may need more. Is this statement clear? Very simple statement. Size of minimum edge cover that will be greater than or equal to n by 2 seal. But if this is equal to n by 2 seal, no. This is greater than or equal to n by 2 seal. Only this we can say. We cannot say this. Okay. What about this question? Is what about this? True or false? Does there exist a connected graph whose minimum vertex cover is V? Like, can you create a graph whose minimum vertex cover is V? What is the size of minimum vertex cover? Like in worst case. In worst case, what you can do? Tell me. Can you create a graph whose minimum vertex cover is V? Means all the vertices you have to take. Is it possible? This is my question. Is it possible that we have to take all the vertices? We have to take all the vertices in minimum, all the vertices in minimum vertex cover to cover all edges. Is this possible? Is this possible? This is not possible. This is not possible. See, don't say me. So don't say empty graph. What is the, for empty graph, what is beta? Tell me, for empty graph, what is beta? For empty graph, for this empty graph, what is beta? Beta means minimum vertex cover. What is beta for empty graph? That is 0. Array, that is 0. You don't have to take any vertex. You will cover all the edges. It exists. Like for example, A, B, C. This is your graph. Now for this graph, if you want to cover, if you want a vertex cover, this vertex cover is enough. You want to cover all the edges. How many security guard are needed? You want to cover all the edges. How many security guard are needed? How many security guard you need? 0. How many security guard you need? 0. So remember, there is a difference. Here you have 0. Don't say not exist. So vertex cover size will be 0. Actually, this is not exist. For example, if you have A, B, C, now tell me, for this graph, the edge cover and vertex cover, think about it. Vertex cover means how many security guard you need to cover all the edges. No security guard needed. So vertex cover will be this. Means beta will be 0. But edge cover does not exist. Edge cover does not exist, because edge cover means edges which will cover all the vertices. You can notice this is covering all the edges. Yes or no? Can I say this is covering all the edges? Can I say this is covering all the edges? Yes, this is covering all the edges. This is covering all the edges. But you cannot do this. This is not covering all the vertices. We are not covering all the vertices here. So this is the difference. Edge cover does not exist. So for this graph, this will be 0. You don't need any security guard. So tell me, is it possible that all the vertices are in vertex cover? What about complete graph? What about this complete graph Kn? What is the vertex cover for the complete graph? For the complete graph, tell me, what will be the size of vertex cover? You have a complete graph. If you have a complete graph, is one vertex enough? Is one vertex enough to cover all the edges? Can you cover all the edges by one vertex? If I put one security guard here, can I cover all the edges? No, I cannot cover this edge, because this is complete graph. Between every pair of vertices, there is edge. So what is the vertex cover? Minimum, how many security guard you need here in this graph? In this graph, minimum, how many security guard you need? Yes, n minus 1. Yes, n minus 1. 3, 2 is not enough. 2 is not enough, because see, why 2 is not enough? Tell me 2 is not enough. Why 2 is not enough? What is the reason 2 is not enough? 2 is not enough because if you take 2, Like if you take two vertices, then the remaining two vertices will have edge. The remaining two vertices will have edge, yes or no? Like let's assume you take two vertices. For example, let's assume you take A comma B. These two vertices you take. Then this edge is not covered. This edge is not covered, yes or no? This edge is not covered. So you need n minus 1. N minus 1 vertices you need. They will cover all the edges. These n minus 1 vertices will cover all the edges. So remember for kn, because this is a complete graph. This is your complete graph on n vertices. You know, this is your complete graph on n vertices. So here, what is the vertex cover? Minimum vertex cover. You need n minus 1 vertices. Okay, tell me n minus 2 is, can I say n minus 2? For example, let's assume these are the vertices. Let's assume these are the vertices A1, A2, A3, an minus 1 and an. Now tell me this thing. Can I say n minus 2 vertices enough? Can I say these many vertices enough? N minus 2. These vertices, are they enough? Are they enough? Like if I take n minus 2 vertices, if I take n minus 2 vertices, are they enough? N minus 2 vertices, are they enough? The answer is no. Because if you take n minus 2 vertices, then the remaining, this edge will, who will cover? Who will cover this edge? If you take n minus 2 vertices, who will cover this edge? This edge is not covered. This edge is not covered. So n minus 1 vertices, no, n minus 2 vertices is not enough. What about n minus 1? Is that enough? N minus 1. N minus 1 vertices enough? Yes, these are enough. Yes. Because if you take n minus 1 vertices, now all the edges are covered. Is this clear? So in the worst case, remember, do you need all the vertices? Will you ever need all the vertices? Does there exist any graph for which you need all the vertices? You will never need all the vertices because n minus 1 vertices will do. In worst case, n minus 1 vertices will do. So the answer is no. Because in worst case, what you can do? Tell me. In worst case, n minus 1 vertices means v minus 1 vertices can cover all the edges. V minus 1 vertices can cover all edges. Yes or no? These many vertices, they will cover all the edges. Every edge will be covered. If you take v minus 1 vertices, every edge will be covered. Yes or no? So quite simple. So we have seen edge cover, vertex cover, these things we have seen. So the minimum number of edges in a edge cover, that is basically v by 2. This is the minimum number of edges in a edge cover. Okay. Tell me, yeah. So this, the covering number of a graph. So you have two covering number. There is vertex covering number. We write it as beta. This is the symbol for is beta, and the edge covering number, the symbol is beta dash. This is the edge covering number. Okay. So you know what is edge covering number? This is the size of minimum edge cover. This is the size of minimum edge cover. Edge cover. And this is the size of minimum vertex cover. You already know. So tell me, for these graphs, first question, for this cycle graph Cn, what is the beta and what is beta dash? What is beta and what is beta dash for cycle graph? What do you think? What is beta? Like this is your cycle graph, this is your cycle graph, this is your cycle graph. Then what is beta and what is beta dash? For this, what is beta? For this, how many vertices you need? If you want to cover all the edges, you need 2 vertices. Here also you need 2 vertices. These 2 vertices will do. These 2 vertices can cover all the edges. Here, these 2 vertices can cover all the edges. Okay, here, this vertex and this vertex, can they cover all the edges? No, they cannot cover all the edges. So here you need 3. And if you have 6, then you need 3. Here also you need 3. So what is beta? What should be the beta? Beta should be n by 2 seal. Beta should be n by 2 seal, right? This should be the beta, n by 2 seal, because when you have 5 vertices, when you have C5, then you need 3 vertices. Okay, so this will be your beta. And what about beta dash? Here, how many edges you need? If you take this edge, then for this actually these two are enough. For this, you can take this edge, these two vertices are gone. Okay, these two vertices are gone. Next, if you take this edge, these two vertices are gone. So basically, and you can take one more edge. Similarly, here you can take these two edges. Here you can take this edge, this edge, this edge. So here you need 3, here you need 2, here you need 3. So what is the answer? The answer is the same. That will be n by 2 seal. Yes or no? Because remember, you already know, this we already know, that beta dash is always greater than or equal to n by 2 seal. This we already know, that beta dash is always greater than equal to. And for Cn, this will be equal. For Cn, this will be equal. Only this is enough. Only this is enough. Yes or no? For Cn. Is this clear? All these points, are they clear? Anyone has any doubt? Tell me, please tell me. Did you understand vertex cover, edge cover? Did you understand? We have taken many examples. Is it clear? Like, anyone has any doubt? Is there any statement which you did not understand? Did you understand this? Like, did you understand this? That beta, that the edge cover, the minimum edge cover is greater than or equal to n by 2 seal. Because one edge will cover only 2 vertices. You know, one edge can cover only 2 vertices. So if you want to cover all the vertices, at least these many edges are needed. At least, because one edge will cover only 2 vertices. 2 vertices are covered by one edge. So at least these many edges you need to cover all the vertices. So this is the analysis for Cn. What can you say about Pn? Path graph. What can you say about Pn? Tell me, what can you say about Pn? N is greater than or equal to 2. Because when n is equal to 1, then what is the problem? Tell me, when n is equal to 1, what is the problem? Edge cover is not defined. If you do n equal to 1, then edge cover will not be defined. This P1. So edge cover not defined, does not exist. So this is the idea. Now, so tell me, what will be beta and what will be beta dash for these graphs? So for this graph, what will be beta? Vertex cover. So one is enough. Here, this will be enough. Okay, next, what about this? You need 2. And here what you need? Here you need 2. Again, you need 2. Yes or no? Here again you need 2. These 2 are enough. And if you have 6, then 1. Okay, this will cover these 2. So this will cover these 2. This will cover these 2. So finally you need 3. Here you need 3. And what about beta dash? Edge cover. What that will be? Here one edge is enough. Here 2 edges you have to take. Here you have to take how many edges? If you take this edge, so 2 edges you need to cover. You need to take this edge. You have to take this edge. You have to take. Then you have to take one more. This edge. So you have to take 3. So tell me, what will be the answer? This is the idea. So for Pn, where n is greater than or equal to 2, then what is beta? The beta is simply, I can say, n by 2 floor. The beta will be n by 2 floor, and the beta dash will be n by 2 seal. The beta dash will be n by 2 seal. Yes or no? See, beta dash is already, you already know this use statement, you already know. For all graph, beta dash is definitely greater than or equal to for all graph. This you already know, for all graph. And for path graph, they will be equal. Is this clear? For path graph, very simple. And what about this wheel graph, Wn? What about it? Wn, wheel graph on n plus 1 vertices. For example, this is your W3. This is the W3. And this is your W4. So tell me, what is beta here? What is the beta here? Remember, this is your this is your K4 actually. This is your K4. So you need 3 vertices. This is K4. This is your W3. This is your W3, and this is same as K4. So this you need 3 vertices. And what is beta dash? For complete graph, what is beta? What is beta dash for complete graph? For complete graph, what is beta dash? Can anyone tell me? What is beta dash for complete graph? If you have Kn, then what will be beta dash? Beta dash means edge cover, minimum edge cover. What that will be? That will be n by 2 seal. That will be n by 2 seal. Because if you have Kn, then what you can do? Because you have Kn, like you have every 2 vertices. Remember, every 2 vertices are adjacent, right? Yes or no? This is your vertex set. Every 2 vertices are adjacent. So minimum edge cover will be like this. This minimum edge cover will work 1, 2, 3, 4, 5, 6, 7, 8, and so on and so on. So like this. So this will come because this is the edge, this is edge, this is edge. Between every 2 vertices you have edge. This is your complete graph. Between every 2 vertices you have edge. So you can take this edge, this edge, this edge, and so on. So finally, your size of minimum vertex cover, the size of minimum vertex cover will be n by 2 seal. Yes or no? That will be n by 2 seal. So like this you can do for Kn. So this will be the idea. Now tell me about this one, this Wn. So this beta dash, this here, because you have 4 vertices, so here it will be 2. 2 edges are enough. For example, you can take this edge, you can take this edge. Both will be covered. What about this? What about beta and what about beta dash here? What will be the beta dash? This edge will cover these vertices. This edge will cover. So I think we will need 3. Yes, minimum. Yes, minimum edge cover. Yes, sorry for that. Minimum edge cover. That is minimum edge cover. Okay. So for this, because you have how many vertices you have? So here you have total 5 vertices. So beta dash actually will be 3. You only need 3. Because you can take this edge, you can take this edge, and then you can take to cover this, you can take this edge. And what will be beta? What will be beta? So this will cover all the edges. These edges will be covered by this. These edges will be covered by this, and plus the Cn, plus the Cn. For the Cn, what is needed? For the Cn, this n by 2 seal will be needed. Is this clear? Like what I'm saying? See, the beta, this will cover all these vertices. Okay, so this will cover all the edges. And there is a Cn around you. This is the Cn, this is the Cn. For this Cn, you need n by 2 seal. For this Cn, you will need n by 2 seal. Correct? And the beta dash is total n by 2 seal. You only need n by 2 seal. Total 6 you have, so only 3 you need. You can take this. Okay, only 3 you need. So I hope you are getting this, because remember in Wn, if you have a Wn means you have there is a Cn. There is a Cn around you. There is a Cn around you. This is your Cn. And there is one vertex here. And there is one vertex here. So what will be beta? Minimum vertex cover. Beta means minimum vertex cover. So what will be your beta? You have to take this vertex. This middle vertex you have to take. This one is for this middle vertex. This middle vertex will cover all these edges. Now all these edges are done. Okay, remember all these edges will be gone. So all these edges will be covered by this A. These edges, they are covered by A. Okay, next, plus now this Cn, you have a Cn around you. Now these edges are gone. All these edges we have covered. But these, what about these edges? What about these edges? These edges. What about these? So for them you need n by 2 seal, right? This is for CN. This is for the CN around A, around vertex A. Is this clear? How to get for wheel graph? The beta will be, this will be the beta. Okay. So remember, by default, the covering number of a graph. If I directly say covering number, then what it means? If I directly say covering number, what it means? It means vertex covering number. Remember, vertex covering number. So by default, if I directly say covering number of a graph, that means vertex covering number. This is the by default. Read this question and tell me which problem we are talking about here. Read this. Let G be a graph whose vertex set represents the set of chemicals. Two vertices are adjacent if and only if they are compatible, means they react. Suppose we want to store a set of chemicals in different rooms. Naturally, we would like to store incompatible chemicals in different rooms. So which problem are we talking about here in this question? Independent set. Very good. Here actually we are talking about independent set, because what this question is saying, that there are some chemicals, like let's assume this chemical, they react. Let's assume these chemicals are reacting. Okay, so let's assume these are reacting, and let us assume that C2 is reacting with C4 and C2 is reacting with C5, and let us assume this is the scenario. Then what we want, so this is the scenario. G is a graph where vertex set is your set of chemicals. These are the chemicals. Two vertices are adjacent if and only if they react. If and only if they react. It simply means that they react. What this means? This means C1, C3 react. They react. Okay. Now the question is saying that what we want to do, we want to put reacting chemicals in a different room. Okay, what we want to do, we want to store, I can say, reacting chemicals. The chemicals will react. We want to store them in different rooms. So this is what we want to do. So what we need basically, so basically we need independent set. I cannot put them together. I cannot put them together. I cannot put them together. So I need independent set. So for example, I can put C1, C5, I can put together. This is fine. I can put them together. C1, C4, I can put together. This is fine. And what is the largest independent set? What is the largest independent set? Tell me. From here, only one chemical I can take. Only one chemical I can take from here. So actually the independence number, what that will be? Independence number will be 2. So this is the largest number of, 2 is the largest number of chemicals you can put together. These two you can put together. These two you can put together. These two you can put together. So here, which problem we are talking about? We are talking about independent set problem. So in the GATE exam, they can give you a problem and they will ask you like what we are talking about. They will give you something like this. And then they will ask you. Actually, this type of questions, they have come in the TIFR. In the TIFR exam, many times it will happen. They will give you a scenario and then they will ask you like, what are we talking about? Like, what is this problem? Is this vertex cover, independent set, edge cover? What is this problem? Click. What is this problem? Okay. So that is the idea.